An octahedron is a geometric shape that looks like two pyramids stuck together. It's consisted of 8 faces and 6 points. We want to create a deformed octahedron shaped like a tower, and we'll use Dynamo and Refinery to find the best solutions. We will start by creating triangle. A triangle will be created using a polygon tool. So let's type polygon by points. We want regular polygon. Now this one needs a base that is a circle. So to take this, we want to create a circle by center point radius. As you can see, here's the circle, because we are set to automatic. Now let's keep the center point as it is, and the radius, let's say we want it to be 20. I'm assuming we are using meters, so let me change to the units to meters now. So this is the circle. The number of sides by default is 5. We want it to be 3. Right, let's hide. Now we want to transform this geometry and create another triangle upwards. So to do this, we want to copy this. But this time, we want a point by coordinates, and this point will have a z value of 20. Now the octahedron shape is consisted of the two triangles that is rotated in 60 degrees from each one. So to do this, we want to use geometry rotate node. The geometry will be the polygon, this triangle. The origin will be the origin point. Let's hide it. The axis will be the z-axis. Degrees, there will be 60 degrees. Okay, let's hide this. Now you can see that the shapes are above each other and they're rotated. Now we want to connect these dots together. We exploded the geometry. Each one of the lines are now separate. And we want to take the, let's say, endpoint of each one of those. And these endpoints, we want them to be connected to the endpoint of each one of the other items. So to create this, let's take the points of the triangle that's below. And let's use line by start point, end point to visualize. If we put this to cross product, we can see that we have the lines we need from the sides, and also we have extra lines that we don't need. As you see, it's 9 lines, but we can remove the items that is in the middle and we can take the shape we want. But the thing is that we want every polygon We want every surface to be an enclosed polygon, and this will make it easier to work with the geometry later. So we don't want to use this method. Join the lists now. And how to join this is by taking points from this list and from this list and selectively choosing every one of them. So I'll use get item at index node, copy it 3 times, and create a list of values, and actually I want to copy this and paste it right here. Now I want to join points, so I'm taking this point and this point. I want to join them with this one. So here it is. You can see that the list is created, but we can't know that this is for sure the shape we want until we create a polygon by point. Here you can see it. I want to use this method all over the shape. To visualize this, I want to create surface by patch. So now you can see that we have all the 6 sides. Let's join. And we also want to use surface by patch node. For the base and top of the geometry. So the first thing we want to add is deformation by height. We simply can go to the top and extrude this. can connect it to a slider. We'll use integer sliders for this example because we are dealing with refinery. Refinery should take an integer to make things easier because the integer will be working with whole numbers. If we used a number slider, for us we can control the step here. But for refinery it will go through many digits and it will take a lot of time, and also it will give a lot of useless numbers that can be optimized when you use integer sliders. So let's make the minimum 30 and the maximum 150, and the integer will be working according to that. Now we want another thing to control, which is the points of triangle. So also we take the endpoints and we will work with them. I'll use geometry, transform, and coordinate system by origin. The inputs will be a geometry, a coordinate system to take the object from, and the context coordinate system or the new coordinate system. So to start off, let's try one of the points. The source coordinate system will stay the same. Now we want to change the context coordinate system. Also we'll connect this to sliders, integer sliders, and we'll call them top P1, which is 0.1 x. This will control the x of the point. This multiplier will be related to the height. So let's say we'll take the height, divide it by 50. And this number will be our multiplier. You can also use this concept with the diameter of the shape. Let's repeat the steps for the remaining points. But before that, I want to note something. We should, to be able to use Refinery, we want to right click here and to define that this ladder will be an input. For now, I want to keep the size of the tower the same. I don't want to mess with that, so I don't want to make those as inputs. Let's keep it simple. Refinery should have different names, so it can be able to identify each one of them. So now, instead of using these inputs for the nodes right here, we want to change each one of them with our new points. So let's select this one and see where it's connected, and we can replace each one of them. We can repeat the same for the second point. And for the third point. Let's hide everything. And see what's the issue. So it seems that in this one we are still using the old one, the old top. So to change it, we want to use the same nodes that's found right here. Here you can see that we have this shape. So we can replace this. And here's our new deformed tower. Please note that we'll still have the same values. What will happen is actually it will be most of the times, and the top will be bigger than the bottom, and I think this will make an issue for us. So let's try to make a solution for this. This is because the numbers are slightly big, so we want to change this x and y. Let's change them to 50. This will make the change less dramatic. The Z will be the same. I don't want to change anything with it. Now here we have these different sliders, and from now we can start to optimize the shape. What we want to optimize is that we want this tower to have the maximum amount of floor area. So to create this, we want to find a way for the computer to calculate each of the floor areas. For now, we'll assume that every 4 meters will be a different floor. We want to create plane by origin and normal. This plane will have the origin of 0, the normal of z, but we want to repeat this 1 by creating a list of points from 0 to a spaced by 4 in the z value. Now a will be the height of the tower, so we want to connect this to the height. And here we can see a list of numbers. So here we have different planes now, and we want to intersect the geometry of each plane with the final shape. Let's move this close together. Here we have 8 surfaces. I want to join them now. By join surfaces and then intersect. Here you can see the intersections are working smoothly until we reach this point. This is because we did some transformation to the tower top. Let's use this shape. And create a bounding box by geometry. This bounding box have a minimum and maximum value. Maximum point for the bounding box, and we want the z value of this maximum point. And we'll connect this here instead of the previous number. Here you can see another issue. This one is that we have some base that's not usable. To fix this, we want to take the minimum point of the bounding box. At the same time, we want to take the z of that point. So here we have the best result. It's the last floor, and this floor can be a mechanical floor or whatever. And we don't want this. So what we have here are a surface in the beginning, because it's intersecting with the surface, and the other are lines. We want to take the rest of items and join the lines using polycurve by joint curves. Here you can see each floor is now a polycurve, and we want to create a surface by patch node. Here you can see all the surfaces, and let's join the first item, which is the surface, with the other surfaces or the rest of items. Now let's use surface area. I want to sum them all. And here we have 44,000 square meters. Let's round this using math floor. And let's right click on this and use as output. Rename it BUA, which is short for built up area. Okay, so now we want to optimize the shape to have the maximum built up area, and at the same time want the minimum surface area. Calculating surface area is pretty easy. To calculate this, I want to take the surfaces and use surface area. And math sum. Here we have the surface area of all the shape. At the same time, I want also to exclude the first shape of the base. So I want to use the rest of items. That's called cladding area. Also, let's round that. Let's make this an output. So now we have 9 inputs and 2 outputs. The cladding area and the built-up area. So to start off, we want to go to refinery, launch refinery. Here in this window you can see that we have studies. We can create a new study. We have these symbols that indicate how we want to show the studies. So now we want to create a new study. The rule in refinery that we should have different names for the sliders. We want to have preferably two outputs and as much as we want inputs. We want also to save the graph. To create this study, the first thing is to optimize. I want to optimize the inputs. The inputs will be as we named them, and here we can select if we want this input to be included or not. The outputs are also as we designated them, built-up area and cladding area. Now we want to maximize the built-up area, but we want to minimize the cladding area. Now the setting, it will be population size and generations and seed. So generations, it will be, let's say, the amount of iterations, the amount of times the software would run and like create new designs. Population area are the number of options within each generation. Let's keep it to default. Seed, it will be the number where the calculations start. Let's keep this setting for now and let's generate. You can see that it's working right now. Here you see you have some results. You can see that there's a flat roof, there's inclined roof, some geometric shape. And at the same time you can see that we have some statistics here. Here's the y-axis and the x-axis. In the beginning it's using some of the input sliders. Actually I want to create the built-up area. I want to designate built-up area and cladding area. At the same time you can see that here are the built-up area and the y-axis, and the cladding area and the x-axis. So we want the minimum cladding area with maximum built-up area. Alright, so here we have the options, and also there's a great setting here that we can visualize the result in Dynamo. Let's put this to the side and go to Refinery again. Let's say if we choose this and see how it changes right now. This one, this one. Now here we can see that we have different inputs. Here you can see that we have different results and different numbers. We can also visualize this by colors and sizes. We can go to this view. In this view it's called parallel coordinates. This one is really great. It helps a lot to filter the results. Now if we select filter and we go to built-up area and cladding area, these two columns, we want every result that is below 18,000 and above 3,050 square meters. You can see that there's no results with such values. If we increase the numbers a little bit, we can see that we have only one result that matches this criteria. So if we have a program, and this program should be minimum 35 square meters, we can make sure that this will be, let's say, a cost, or like the surface area of 18,000 square meters. Here we can see that this shape automatically updated, and I see it's a pretty cool one. Thanks for watching. Next video we'll do some more details. We'll fix some of the issues in the triangle in the beginning and the bottom of the building, and also we'll make some adjustments that related to the inclination. We want a certain degree of inclination in the building, so we want to minimize the cost and make it constructible, and some other parameters that's related to optimizing the shape using Refinery. I hope you enjoyed it, and thanks for watching.